Chapter 2, Acids, Bases and Salts, Class 10th CBSE based. Contents, as per Class 10th syllabus. Their definitions in terms of furnishing of hydrogen ions and hydroxide ions, general properties, examples and uses, neutralization, concept of pH scale, definition relating to logarithm not required, importance of pH in everyday life, preparation and uses of sodium hydroxide, bleaching powder, baking soda, washing soda and plaster of Paris. Acids. Acids are substances that furnish hydrogen ions when dissolved in water. Properties of acids. Taste, sour, for example, lemon, vinegar. Corrosive in nature. Turn blue litmus paper red. React with metals to produce hydrogen gas. Chemical behavior. They ionize in water to release hydrogen ions. Example. When hydrochloric acid is dissolved in water, it ionizes to produce hydrogen ions and chloride ions. Examples of acids. Strong acids, hydrochloric acid, sulfuric acid, nitric acid. Weak acids, acetic acid, carbonic acid. Bases. Bases are substances that furnish hydroxide ions when dissolved in water. Properties of bases. Taste, bitter. Slippery to touch, for example, soap solution. Turn red litmus paper blue. React with acids to form salts and water. Chemical behavior. They ionize in water to release hydroxide ions. Example. When sodium hydroxide is dissolved in water, it dissociates into sodium ions and hydroxide ions. Examples of bases. Strong bases, sodium hydroxide, potassium hydroxide, calcium hydroxide. Weak bases, ammonium hydroxide. Salts. Salts are formed when an acid reacts with a base, resulting in the neutralization of H ions from the acid and O ions from the base. General reaction, acid plus base, salt plus water. Example. When hydrochloric acid reacts with sodium hydroxide, it produces sodium chloride, common table salt, and water. Types of salts. Neutral salts, formed from a strong acid and strong base. Example, sodium chloride, potassium chloride. Acidic salts, formed from a strong acid and weak base. Example, ammonium chloride. Basic salts, formed from a weak acid and strong base. Example, sodium acetate. Indicators. Indicators are substances that change color or physical state when added to acidic or basic solutions. They help identify if a solution is acidic, basic, or neutral without changing its chemical composition. They act as visual cues. Types of indicators. Indicators are categorized based on their nature. 1. Natural indicators, derived from natural sources such as plants. Examples. Litmus, obtained from lichens, turns red in acidic solutions and blue in basic solutions. Turmeric, turns yellow in neutral or acidic solutions and red in basic solutions. China rose, hibiscus produces different shades of color, dark pink red in acidic solutions and green in basic solutions. 2. Synthetic indicators, chemically synthesized substances used to identify the nature of a solution. Examples. Phenolphthalein, colorless in acidic solutions and pink in basic solutions. Methyl orange, red in acidic solutions and yellow in basic solutions. 3. Olfactory indicators, indicators that work by changing their smell in acidic or basic conditions. Examples. Onion extract, retains its smell in acidic solutions but loses it in basic solutions. Vanilla extract, loses its smell in basic solutions but retains it in acidic solutions. Examples of indicators and their behavior. Indicator. Color in acidic solution. Color in basic solution. Litmus. Red. Blue. Turmeric. Yellow. Red. Phenolphthalein. Colorless. Pink. Methyl orange. Red. Yellow. China rose. Dark pink red. Green. Chemical properties of acids and bases. 1. Reaction of metals with acids and bases. A. Reaction of metals with acids. Acids react with metals to produce hydrogen gas and a salt. General equation: metal plus acid salt plus hydrogen gas. Example: zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. Test for hydrogen gas. When a burning splinter is brought near the gas, it burns with a pop sound. B. Reaction of metals with bases. Only reactive metals, for example, aluminium, zinc, react with strong bases like sodium hydroxide to produce hydrogen gas and a salt. General equation: metal plus base salt plus hydrogen gas. Example: aluminium reacts with sodium hydroxide. Aluminium reacts with sodium hydroxide and water to produce a complex salt called sodium aluminate, in aqueous form, and hydrogen gas. 2. Reaction of metal carbonates and metal hydrogen carbonates with acids and bases. A. Reaction with acids. Acids react with metal carbonates and metal hydrogen carbonates to produce carbon dioxide gas, salt, and water. General equation: metal carbonate plus acid salt plus water plus carbon dioxide. Examples: calcium carbonate reacts with hydrochloric acid. When calcium carbonate reacts with hydrochloric acid, it produces calcium chloride, water, and carbon dioxide gas. This reaction is characterized by bubbling due to the release of carbon dioxide and is commonly observed in antacid reactions. Sodium bicarbonate reacts with sulfuric acid. Sodium bicarbonate, or baking soda, reacts with sulfuric acid to form sodium bisulfate, water, and carbon dioxide gas. This reaction releases carbon dioxide, causing fizzing, and is frequently seen in baking and cleaning processes. Test for carbon dioxide gas: passing the gas through lime water turns it milky, confirming the presence of carbon dioxide gas. B. Reaction with bases. Metal carbonates and metal hydrogen carbonates do not react with bases. 3. Reaction of acids and bases with each other. Neutralization reaction. Acids and bases react to form salt and water. General equation: acid plus base salt plus water. Example: hydrochloric acid reacts with sodium hydroxide. When hydrochloric acid reacts with sodium hydroxide, they undergo a neutralization reaction, producing sodium chloride, NaCl, in aqueous form and water. This reaction is exothermic and is commonly used to demonstrate acid-base neutralization. 4. Reaction of metallic oxides with acids and non-metallic oxides with bases. A. Reaction of metallic oxides with acids. Metallic oxides are basic in nature and react with acids to form salt and water. General equation: metallic oxide plus acid salt plus water. Example: copper 2 oxide reacts with hydrochloric acid. When copper 2 oxide, a metallic oxide, reacts with hydrochloric acid, it forms copper 2 chloride in aqueous form and water. This reaction demonstrates that metallic oxides are basic and react with acids to form salt and water. B. Reaction of non-metallic oxides with bases. Non-metallic oxides are acidic in nature and react with bases to form salt and water. General equation: non-metallic oxide plus base salt plus water. Example: carbon dioxide reacts with calcium hydroxide. When carbon dioxide reacts with calcium hydroxide, also known as lime water, it produces calcium carbonate, a white precipitate, and water. This reaction is used as a test for the presence of carbon dioxide, as the white precipitate turns the solution cloud. What do all acids and bases have in common? Both acids and bases ionize, break down, in water to produce ions. Acids release hydrogen ions in water. Bases release hydroxide ions in water. Universal indicator. A universal indicator is a mixture of dyes that shows a range of colors depending on the pH of the solution. Acidic solution, red or orange. Neutral solution, green. Basic solution, blue or purple. pH scale measures the acidity or basicity of a solution on a scale of 0 to 14. pH 7, acidic. pH is equal to 7, neutral. pH 7, basic. Strong acids, strong bases, weak acids, and weak bases based on the pH scale. Type. Degree of ionization. pH range. Examples. Strong acid. Complete ionization. 03. Hydrochloric acid, sulfuric acid, nitric acid. Weak acid. Partial ionization. 46. Acetic acid, formic acid, citric acid, found in lemons. Strong base. Complete ionization. 11-14. Sodium hydroxide, potassium hydroxide, calcium hydroxide. Weak base. Partial ionization. 8-10. Ammonium hydroxide, magnesium hydroxide, baking soda solution. Some important chemical compounds. 1 common salt, sodium chloride. Source, found in seawater and as rock salt. Uses. Cooking and preserving food. Raw material for various chemicals like sodium hydroxide, baking soda, and washing soda. 2 chloralkali process. A process used to produce sodium hydroxide, chlorine gas, and hydrogen gas from brine, concentrated solution of sodium chloride, using electricity. Chemical reaction. Products and their uses. Sodium hydroxide, used in soap, paper, and artificial silk industries. Chlorine, used for water purification, making PVC, and disinfectants. Hydrogen, used in fuel, margarine, and ammonia production. 3. Bleaching powder, calcium oxychloride. Preparation. Bleaching powder is prepared by passing chlorine gas through dry slaked lime. Properties. Appearance: white powder with a strong smell of chlorine. Solubility: slightly soluble in water, forming a milky solution. Uses: disinfecting water, added to drinking water to kill germs and bacteria. Bleaching agent, used in the textile and paper industries to bleach cotton and paper pulp. Oxidizing agent, utilized in chemical industries for various oxidation reactions. Sanitation, helps disinfect sewage and control odors in public health applications. 4. Baking soda, sodium bicarbonate. Baking soda is manufactured using the solver process, which involves the reaction of sodium chloride, ammonia, and carbon dioxide in water. Sodium bicarbonate precipitates out due to its low solubility and is then filtered and dried. Properties. Appearance: white crystalline powder. Taste: slightly salty and alkaline. Solubility: soluble in water. Nature: mildly basic, it reacts with acids to release carbon dioxide gas. Uses: baking soda. Cooking: acts as a leavening agent in baking. It releases gas when heated or combined with acids, causing dough or batter to rise. Antacid: neutralize excess stomach acid to relieve indigestion. Cleaning agent: removes stains and odors due to its mild abrasive and deodorizing properties. Fire extinguishers: releases gas to smother flames. Laboratory use: used as a neutralizer in chemical reactions involving acids. 5. Washing soda, sodium carbonate decahydrate. Washing soda is produced by heating baking soda, which decomposes to form sodium carbonate. Sodium carbonate is then dissolved in water and recrystallized to form washing soda. Properties. Appearance: transparent crystals that effloresce, lose water of crystallization when exposed to air. Solubility: highly soluble in water. Nature: a strong alkaline compound that turns red litmus blue. Chemical formula: sodium carbonate decahydrate contains 10 water molecules as water of crystallization. Uses: washing soda. Cleaning agent, commonly used in detergents and soaps to remove dirt and grease. Softening hard water, removes calcium and magnesium ions from hard water, making it suitable for cleaning and washing. Manufacture of glass acts as a flux in the glass-making process by reducing the melting point of silica. Paper industry, used in the manufacture of pulp and paper. Dyeing, helps to fix dyes during the dyeing process. pH regulation, maintains alkaline pH in chemical reactions and pools. 6. Plaster of Paris, POP, calcium sulfate hemihydrate. Preparation. Starting material, gypsum. Plaster of Paris is produced by heating gypsum at around 373 K, 100 degrees C 120 degrees C. This removes water molecules, converting gypsum into hemihydrate. Properties. White powder sets into a hard mass when mixed with water. Uses. Making molds and casts. Construction material for wall finishes and false ceilings. Orthopedic purposes for making casts.